Okay, so spit cups, spittoons, inkwells, unspillable cups, glue containers. These are all different things that use this design. Now, this design is really cool. So if you're going to make an unspillable cup, what are the different considerations you have to make? And so what you have to do, you have to make sure that in the cross section of your cup that three different areas are all equal. You have to make sure that this area down here is the same as this area in here, and then which is the same as this area in here with these two parts. And so by playing around with the size of this, you can get these three different areas to be equal. Now, you don't want them to be completely equal because you don't want it to spill, and so you don't want this level to come all the way up to here, because then when you tip it over it, it'll have a chance of spilling out. And so likewise with this area here, you don't want it to come all the way up to here. You have to have a little bit of buffer room for the liquid for when you're tipped over on your side like this, so that the liquid has a place to go. And then when you're upside down like this, you don't want it to go above this level. And so it's kind of interesting playing around with the numbers, because it's not an exact thing, and there's some play, and there's a lot of different stuff you can play with. So one problem with these types of cups is, so if you're using it as a vessel to take liquids out of, like in like an inkwell or a glue container type situation, then we're perfectly fine. You just put a cover on top. But if you're using it in a situation where you're using it to expel stuff, like in the spit cup example, then it can be hard to tell when exactly it's full and ready to be emptied. And like your opening here is dark and it's hard to see. And so how could you tell when the cup is full? So the classic way you might solve this would be using a float. And so you might have like a little maybe an extra tube on the side with a little ball in it, and that ball is buoyant, and then when the ball floats with the liquids, and then once it gets up to a certain point, you're able to see it. And so maybe in this situation here, it wouldn't be a ball, but maybe it would be some type of rectangular thing like this, that when it's full, a little rectangle would pop up out here, and you'd see that your stuff is full. But when you're, especially in the example of a spit cup, the liquid is dirty, and so floats don't work well in that situation. I know I had one of those cat fountains, and it used a float to determine when it was out of water, so it would shut itself off, and it constantly have to clean that just with water, all the contaminants just in the tap water. And so in this situation here, where like spit's really dirty and whatnot, a float doesn't really work for determining when it's full. And so a funny thing I thought of would be, what if you used a whistle? So let's draw this again. So we have our basic unspillable cup. And so maybe on the edge here we'd have a little mouthpiece, and it has a little air tube that runs down, and it extends down past this a little bit, so that past this boundary, so that it'll detect before it gets past that point. And so you have a little whistle here, and when you blow into the whistle, it's going to produce one note, and when you plug off and if you have a tube on the end of a whistle, and you get like an instrument like a recorder or a tin whistle, and by extending the tube, you change the note, and then you can, by having a hole and closing off the hole, you can change the note as well. And so I did some experiments to see, like, because normally you're closing off the hole with your fingers with flesh, or you're closing it off with the material that the flute is made of. But could you mute the hole with a liquid to change the note of the flute or the whistle? And it turns out you can. That the water, that you just, as long as the hole is plugged, then you've changed the length of the flute, and so it's able to resonate at that new note. And so all you would need to do is you have a little whistle here, and you blow in it. It produces a high note when it's empty, and then once it would fill up and plug off this point here, you blow into the whistle, it would produce a low note, and so you'd know it's full. And then if you weren't as musically inclined, you could, to be able to tell, you know, the high note from the low note or whatnot, less simple, you just put in a second whistle at the top, and the second whistle just produces the same note no matter what. And so then dissonance is something that's fairly easy to detect for most people, and so you would blow into the whistle when it's empty. It would produce two pitches that are the same tone, so it would sound like, and then when it would be full, this second note would change, and you get some dissonance, and it would sound like when you would blow into the whistle, and then you would know that the vessel was full. So cool idea. So would have had a 3D printer and could have built it, but don't need it now. The sense resolved the issues I had that I needed a spit cup, but no, cool idea.